Here are the solutions to the exercises from Chapter 15 on dynamic memory.
This is floats.c. Here's where I solve the problem of having three different types of memory, my array of 150 floats done three different ways. So let's look at them in turn. I've got a little hash define here saying how many I want to have, which will just be the quantity required, which equals 150. Now the first one here is the static version. There's actually a few different ways of creating memory in the static area. The first is to simply create a global variable like this. Now this variable will obviously be accessible from this .c file and any other .c file in this program. There's only one, but if there was more, this could be accessible by those as well. Now that memory is indeed in the static area. Now I could also go and simply add the static keyword to the front of that. Now that would also be in the static area. The only difference would be the scope would be different, in that if there were any, would not be able to access this particular variable. And the third way to create memory in the static area is to actually move that down into here. Now that is still in the static memory area, but it's now got a completely different scope. The scope is completely restricted now. It's restricted down to just the main function. And I think I'll leave it there because then I've got all my three different ways of doing it all in a row. Now the second one, which is the stack variables, they're actually the simplest of all. I just declare a variable inside my main function, and that will of course be put on the stack. And the third one is the heap one, or the dynamic version. Now what I've done here is I've simply created a pointer to a float, or if you like, the memory address of a float. Now that does not actually create 150 floats. In fact, it doesn't create any floats. It simply creates the address of a float. So what I've got to do, of course, is go down here and start using malloc to create them. So here's where I use malloc, and here's where I say how big the area of memory is that I want. Obviously I need 150 of them, and each one is going to be of size float. I don't actually need to know how many bytes each float actually is. That's what I have size of for. Then if I check to see whether malloc actually was successful in allocating that memory. I strongly recommend that you do that too. I know that you probably didn't do it just for this exercise, but I'd get in the habit of doing it if I were you. Now if that didn't work, then malloc failed, exit 1 and so forth. Otherwise I need to do a free. Again, you probably don't need to do that for just this little simple exercise, but again, it's good to get in the habit of doing it right from the word go. Okay, so there's three different arrays of 150 floats done three different ways. Let's move on. Look at the second question, which is about average.c. So it's a pretty straightforward program. I've created myself a variable here, which is going to be the actual array of integers. That array allocated on the heap by using malloc or whatever, and once it's allocated, then this variable, this pointer, is going to be used to point to that array, and I will treat that then as an array. So the first question, of course, is how big should the array be? How many numbers do I want to average? So once I've got the count, I can then use that as part of my calculation for how big the memory should be. It's obviously going to be count times the size of one int. And again, I should check to see if the malloc succeeded, and if not, then simply exit the program because there's nothing else I can do. Then I can go through the standard procedure of reading in the number, using scanf and adding it into the total. That's all pretty straightforward. But notice, this is the tricky part, I have to take the address of the ith element of the array each time. Remember, with scanf you always have to provide the address of whatever it is that you're reading the data into, and the data that I'm reading everything into at the moment is one of the elements of the PTR array. In fact, it's the ith element of the PTR array, so I have to provide the address of the ith element. I know that's a little bit tricky. It's probably the only tricky part of this entire program. Once it's successfully read in, though, of course, assigning it into the total or accumulating it into the total is a very simple matter. Okay, and again we free it at the end and display the average. So that's pretty much all there is to that program. Now let's go and have a look at the course solution. Okay, so let's have a look at it. The first place we'll look is in the header file because some changes were actually made in there. Let's have a look at that. The principal change in the header file was in the title and artist. Title and artist are now no longer arrays of characters. They're actually pointed to characters, and each time we create a new CD we will have to allocate space for the title and for the artist. Obviously, once we've allocated that space, we'll take this particular pointer and this particular pointer and assign those to each of the memory areas that we've created. So that was pretty much the only change in database.h. Now there were some fairly substantial changes made to main.c. Let's go and have a look at those. Now we needed stdlib.h because we're doing some mallocing now in main.c, and here's the first change. This is probably the most important change that we're going to make. The CDs now is no longer an array, it's just a pointer. It's a pointer to a CD structure, or put another way, it's the address of a CD structure. Notice I don't have to have any array details anymore because there is no more limitation on the number of CDs that this program can hold. Now, I didn't mention this before, but in database.h we also got rid of all of the hash defines. We don't need a hash define that tells us how many CDs our program can handle because there is no limit anymore. We're only limited by the amount of memory. In other words, we can keep going until malloc tells us that we can't have any more. Nor is there any limitation on the size of the title or the artist. They used to be 60 characters each, but now they're essentially unlimited. Moving right along, now we used to have a message here that told us the maximum number of CDs that our database could hold. We don't have that message anymore because there is no maximum. So the very first thing I'm going to do now is ask them how many CDs that we have to enter. Now that will then determine the maximum that our program can support. Now I'm using the little readint program. I created readint function before, so I might as well use it every time I want to read in some kind of integer. Now this is obviously going to be an integer, so I might as well use it and save myself a bit of programming. Now that number that we get back is going to be stored in count, so I can then use count to decide how many bytes worth of information I'm going to set aside for my array of CDs. And again, I really do need to check whether there is enough for that. The user might have been really silly and typed in something like 100 billion, and I'm clearly not going to be able to malloc 100 billion bytes, or 100 billion times the size of a CD bytes. Now reading in of the CD is actually now quite straightforward. We used to have a forever loop here, but now it's just a very straightforward for loop. I don't have to have a question at the bottom saying, do you have any more CDs that you wish to enter, because I know exactly how many they're going to enter. And of course the printing out of these CDs did not change very much at all. Now of course you can see that the reading in of the CDs and the printing out of the CDs here is almost exactly the same code, and I like it like that. It's more consistent. Finally, the only changes that we've made at the bottom are that we need to free up the title and the artist. Now I haven't actually shown you the bit of code where the memory is actually mallocked for title and artist. I'm going to show that to you shortly, but it's fair to assume that they do get mallocked at some point, so if we've got a CD we need to free the title and the artist. Once we've been through this loop and freed all the title and artist strings, we can then go and free the CD array itself. Now what you don't want to do is take that line of code and put it up here above the for loop. You absolutely do not want to free the CD array first, because what that would mean would be that you're freeing some memory, and then immediately after you're freeing the memory you're actually trying to access exactly that memory again and do something with the contents of that memory. So the freeing of the CD array has to be done last. Now the only other changes were made in the reading program, so let's go and have a look at that. So all the reading in is done in input.c, of course. Let's look at the modifications I've made to that. Well, firstly I had to add this little horrible line of code here to undefine a compiler define called strict ANSI. That was needed because the dev C++ compiler that I'm using has some troubles with this particular file. And that is actually a bug in dev C++. There's nothing wrong with the actual code. Now, if you are using dev C++, then you'll obviously have to leave that line in, but otherwise that line is completely unnecessary. Otherwise, I have added this line because I'm going to be doing some string manipulation in this file, and I've also added this hash define here, which we'll talk about in just a moment. Now, all the changes are just down the end of the file, so I'll go down there now, and we'll look at read CD. Now, this used to say something completely different. This used to be a read string. It used to say read string across here, and then we would have the prompt, which is like that. Then we would have CD pointer to title, and then we would have the size of CD pointer to title. But I've decided to do it a little bit differently now. I've written myself another function. Instead of read string, I've created a second function called read dyn string, which is short for read dynamic string. In other words, read a string into memory dynamically using dynamic memory, and I'm going to use that to read in the title and artist. Now, read dynamic string works a little bit differently to read string in that it actually gives us back as a return value the string that represents the title or artist or whatever. I can then, because title is now, the field title is now simply a pointer, I can set that pointer to point to the piece of memory that is returned by read dynamic string. All I have to ensure is that in read dynamic string I actually return a pointer to a piece of dynamically allocated memory. So let's go and have a look at that now. That's just up above, and here it is, read dynamic string. Just a couple of notes from the comment here. The string is dynamically allocated. It's very important that I put that comment in there because someone who comes along and reads this and wants to know how to use this particular function must know that the value that they get back from this function is a piece of dynamic memory and thus needs to be freed. Otherwise, they probably wouldn't remember to free it, and we would start losing memory. Now, the way I've decided to implement this particular function is by creating a little string here. This string is actually on the stack. It's not dynamic at all. It's an actual little buffer where I'm going to read the data that the user types in from the keyboard into. Now, how big will that buffer be? Well, I'd like to make this pretty large as any user answer could ever be. So I'd like it to be larger than any title or any artist or anything that I ever might want to read from the keyboard. So that's that little hash define up the top of the program, which is max of 200. So I've actually decided that 200 is as big as I ever need it to be. So I declare that string on the stack and then promptly read into it. I read whatever the user types directly into that string. Then I remove the new line from the string, and then, and this is the clever part, this is the dynamic memory part, I call a function called strudup. Now, if you haven't seen strudup before, it's a function that makes an exact duplicate of the string that you pass it. But it does so dynamically. In other words, it mallocs a bit of memory. Inside the strudup function is a little call to malloc, and the string that you get returned is guaranteed to be dynamically allocated. So I can simply pass that string back out to whoever called this function. So that's the last piece of the puzzle, and the program will work beautifully.
Let's go and compile. We've got no errors. Let's run. How many CDs do you have to enter? Well, what happens if I type 0? Oh, good. Exit the program. Let's try that again. Now I'll just try it with a maximum of 1 CDs, and this will be, well, just some 3. Is a CD an album? Yes. Retail price $5, and that's all there is to it. Very nice. So it's working. So that concludes the chapter on dynamic memory. How did you go with those solutions?